Hello again, my statisticians. This is Professor Sampson from PS I Love Math. Back again with another statistical banger. We just putting them out. I'm just banging and banging and banging and banging, just putting them out. The only thing I'm changing is my glasses, it seems like. So 4 videos a day, trying to get them pumped out, to get them to you so that you have them ready and available. But enough chatting. Don't forget to comment, like, and subscribe to my channel. You know I'm on that road to 1,000 subscribers. Tell your friends, family, cousins, and in this quarantine time, all those people trying to teach themselves math, tell them to come right here where I can teach them the math. Anyway, enough of that. What are we doing today? We're still continuing our talk with confidence intervals with 2 samples. But now the last 2 were independent samples. We're going to move on to dependent samples. And along with the dependent sample, we also get to use our calculator and work through it and have a list. So enough talking, just make sure you subscribe to my channel and it'll be over here somewhere in pink, you know, my favorite color. So as usual, let me share my screen so we can get this party started. All right, so what's our problem now? Always a surprise. A problem is always a surprise. Bam, there it is. All right, so at the beginning of an elementary physical education class, students are asked to do as many sit-ups as possible in a 1-minute period. I know this is true because my daughter had to do it. After practicing the proper technique for doing sit-ups, the students are once again timed to see if they've increased the number of sit-ups they can do in 1 minute. Use the table of results to create and interpret a 95% confidence interval for the true mean change in the number of sit-ups that students were able to complete in 1 minute after the training. So they do this in a lot of elementary schools, you know, pre-COVID, when it was actually in school doing those things. I would have worked on it, my daughter worked on it, everything, and she did her sit-ups before and after and was so excited that you know, that she was able to do them, okay? So let's get started. So what we're gonna do first we're gonna list all our knowns, but we don't have any knowns. The only thing we know is that alpha is equal to what? Again, alpha is equal to 0.05, right? That's the only thing we know. We know it's a confidence level, so we're gonna need alpha over 2, 0.05 over 2. We know we're going to need that. So again, don't be afraid to use your calculator, and I'm going to write it neater. That's 0.025. So that's really the only thing we have right now. What the filth are we going to do with this? Okay. Well, first we need to find a formula that talks about confidence intervals for the difference between 2 means. So this is a different formula, different than the other 2. And hopefully, like I always say, your instructor may give you hopefully give you a formula sheet. If they don't, sucks to be you. All right, so we're going to look at the formula sheet and check it out. I can say that because my instructor never gave us a formula sheet. So here is the formula here, and this right here is the margin of error. I just put E there, okay, just so you know, but that's the formula for the margin of error, which we'll put in later on. That's how I do my problems, and my students can do their problems. So let's pull out this formula here. The formula is D bar, that's the difference between the 2, minus E. And E can be E in whatever letter your book is using. My book uses E right now. At one time it used M for margin of error. It really doesn't matter. And then D bar plus E. D bar is like what? X bar, all right? That's what it is. But it's going to be the mean difference between the 2. That's why it's D instead of X. So the mean difference between these 2 right here, between before and after, all right? Between the first one and the second one. And if you've looked at any of my videos, you know, this is like X and Y, and we know that D bar is Y minus X. And again, for this particular book or for my classes, we use that Y minus X, and we're always going to assume that Y is the second one, all right, because D is Y minus X. Okay, so anyway, let's get these up together, and we're going to waste no time because I don't want to make these videos any longer than they should be. So what I did is, if you can pause it here, or if I was monetized, I would throw in a commercial here or whatever, an ad here, but I can't. But we're going to go right here and we're going to check out how to put this in the calculator. So make sure you pause and write down the number so you can put it in, because I already put it in to save time. Of course, you go to stat and you go to edit, and you're going to put the first list in list 1 and the second list in list 2, which I already have those numbers put in here. But I didn't do the rest because I want to show you how to do the rest in case this is your first video of looking at differences. All right, so you can go over here and you go up to L3. Right? You go up to L3, and remember we're using y minus x, so we're going to put in L2 minus L1. So we're going to have second L2 minus L1. Okay? Then we're going to hit enter, and it's going to populate those differences for us. Okay? Now that's L3. Now really we have no more, not really, actually, we have no more use for L1 and L2 in this situation, because our question is focusing on the difference between the two, which is all in L3. And this will be important in a minute. So let's real quickly take a look at it. We need D bar, which is the mean difference, all right? We want the mean of the differences. So the easiest place to do that in your calculator right away, again, I do these steps the way I do these steps. You can like them or not like them, but that's the way I do these steps. The easiest way I find is just to go to stat, calculate, and one variable statistics. I already put in second L3 right here. If you have an 83, please comment down below on your 83 and I will let you know how to do it on the 83. It's the same thing, but it gives you the commas later. The 84 is a little bit more intuitive. So comment down below if you have an 83. So L3, you go down to here and then you hit calculate, all right? And right there where it says X bar, that's your D bar, okay? X bar is your D bar, and where it says S sub X, there's no such symbol, but in the calculator, that is the standard deviation of the sample, which we will find out that we will need in a minute, okay? So let's write down why we need that. Well, why would we need that? Well, what's the formula for E that we need to write down? E is T alpha over 2 times S of the difference all over, and that should be a little d, but I didn't want to write it little, the square root of n. Okay, that's what E is going to be, and we're going to just plug in the numbers for E, T alpha over 2. So we're talking about T of what? We're talking about T of 0.025, right? All right, so let's plug in these numbers. Now, if my students were asked for the margin of error, they would have to round it to 6 decimal places. Or if they write it down here, it has to be rounded to 6 decimal places, okay? So that takes care of that part. So let's put in these numbers. So first thing we need is T alpha over 2, all right, T of 0.025. Well, to find T, we know on the T chart we need what? I'm going to put it to the right. No, I'm going to put it under here, degrees of freedom. And degrees of freedom is n minus 1. And how many do we have? 2, 4, 6, 8. We have 8, right? If you didn't know, that's also in the calculator. 8 minus 1 is 7. So your degrees of freedom is 7. Again, if you didn't know what n was, you could look in your calculator right there. You see n is equal to 8, okay? So now we're going to go on the degrees of freedom is 7, and we're looking for 0.025. Let's go to our T chart. All right, so degrees of freedom. Let's scroll up. Is 7 at 0.025, so we look in here. So you see 7 at 0.025 is 2.365. So 2.365. So that's T alpha over 2 is 2.365 times the standard deviation, all right, of the difference between the two. That's going to be on your calculator. Now, my students know they have to round properly. Now, what's the proper rounding rule? The rounding rule is one more than is listed in your, one more decimal place than is listed in your data. Our data has no decimal places, right? None. So we should have 1 decimal place. That is written jacked. And it's written jacked again. But anyway, 1 decimal place. I'm not even going to erase it and rewrite it. So we need to have 1 decimal place for our standard deviation. So let's just check it out here on the calculator. So our standard deviation should be 6.5 when you write it down, 6.5, okay? So 6.5 over the square root of 8. Now, again, I don't know how your instructor does it. Now, my students can leave it at this point. If they decide to write down an E, if they decide to write down E equals, they need to write it in 6 digits. So let's do it, 2.365. Let's just do it real quick. I'm going to do some fancy fraction work here. And that standard deviation was what? 6.5 over the square root of 8. So if my students decided to, again, your instructor may be different. So they would have to write down 5.4349999. All right, because they have to have 6 decimal places. If they decided to write it down, they don't have to write it down. But if you decide to write it down, it has to be written down properly. 5.4349999. So if they wanted to write down 5.434999, then they would get credit for it, for the final digit. But if they didn't round to the proper digit, then they would get it marked wrong. All right. So we know what our D bar is, our D bar, which is X bar. So our D bar, and that's why usually when I'm doing these things, so you don't have to keep going back and forth, you should really write them down as you go through the problem. So D bar, again, now and I'm jacked it up. All right, was 10.75. Again, this needs to be rounded properly when you write it down. It's 10.75, so it's 10.8. So D bar is 10.8. All right. So you got 10.8. Now I could put minus E, right? Or I could put minus that 5.43. I'm not writing all that. So minus E, mu sub D, is less than 10.8 plus E. Good enough. Now we go to our calculator and we run the test because the calculator is going to keep all of our digits. So we go over the test and we're actually running what kind of test? Now this is where students get confused, okay? Even though we use 2 samples, we're not dealing with the 2 samples. We're dealing with the difference between the 2. So we actually only have 1 line that we're going to be talking about. And that 1 line that we're going to be working with is a t-test. All right, is a t-test interval. That's what you're looking for, not a 2 sample. So t-test interval, which is number 8. Now we're at this point. I didn't do an example like this, so that's why I say you should watch, continue to watch, and tell me if you continue to watch and you found this interesting in the comment below. All right, so you have data and you have stats. So this time we have data and we're going to move over to data, right? Because there's data in there and it's asking us, which I already put in, where do you want the data to come from? And I'm going to get it from line 3. That's where the difference is, okay? So then I don't need anything. Please leave frequency alone. And I think it was 0.95. Just make sure you don't put in like 95%. It won't calculate that. You have to put it in as a decimal. All right, as 0.95, go down here and hit calculate. So as you can see, you see an answer pops up on your screen. Again, depending on your instructor on how they want their final answer written. But my students know that the final answer should be written as rounded properly. So let's see. The proper rounding for this particular problem would be what? 1 more decimal place than is listed in the data because we actually had data and we had whole number data. So let's see what we're going to have here. So anyway, we're going to have 5.3. If you hear anything, it's my children in the background, you know it's COVID, so they don't know how to act. Mu sub D is less than, what was that, 16.2, I think. I'm checking in a minute to make sure I'm not giving you the wrong answer. Yeah, 16.2. You see that 16.18, which is rounded to 16.2. So as they said, create the confidence level, right? That's your confidence interval. It says create and interpret. All right, create and interpret. So it's time for me to interpret. Those of you who've watched my other videos already know we interpret. I type it out. So let's see what our interpretation is for this one. So interpretation. Yes, I type this in real time so you can see. So our interpretation is going to be what? We are what? We are 95% confident, right? That the mean increase in the number of sit-ups right? Right, we go ahead that the mean increase of the number of sit-ups completed in 1 minute right? After the training, just type the whole thing, right? After the training, right? And you can say to do proper sit-ups, I might say, after the training to do sit-ups properly. Let's say to do sit-ups properly is between, right? Now we write that is between 5.3 and 16.2. All right. You can say for the population of students sampled or whatever. Okay. So that may be enough for your instructor. That's definitely enough for me and enough for this video. I don't, again, want to constantly make it longer. Right. Right. So that's your interpretation. There's your confidence level. That's your interpretation. And you have done a confidence interval for 2 samples where the sigma is unknown. Who knows where sigma is, right? And we are doing dependent samples. So that's how you run through your problems. Remember, in all of these problems, when they ask you for a confidence interval, you know you're looking for a confidence interval. You know you're breaking it down into 2 sides, right? So you're going to divide your confidence limit, your confidence level in half, the decimal place in half, so you can get the 2 sides. Then you're going to choose the appropriate formula and use that formula and work through that formula with the charts along with your calculator, and that will make you a better statistician. So that takes care of video 3 in this series of confidence intervals. There's one more video in this area so that you can get used to it and know how to do them all. So thank you. This is Professor Sampson from PS I Love Math. And don't forget to click the subscribe button, which is over here somewhere. And there is one more video, or you should check out the videos that are already listed somewhere above my head. All right. So thank you and see you soon. Bye.